Okay, here we are for Lab 6. This program was going to read the encoders of the robot and keep them consistent to drive the robot forward 36 inches and then wait 2 seconds and reverse 36 inches. So here's the code. What it includes, be able to access the encoders, the motors, the button, defining our variables for our magic numbers, the wheel diameter, counts per revolution, the distance to travel, 36 inches in centimeters. Delay, these are initial speeds. They were helped develop through Lab number 4 and stop motor. Num pulses, this variable is so that we can calculate the amount of pulses needed to travel the 91.44 centimeters. Here's our setup function. Start our serial connection. We call the count for distance function, which brings back our pulses, and then we call the button press function, which waits for the button to be pressed and then gives a 2-second delay. They are down here. Button press here. There's our delay, and count for distance, so that we can count how many pulses we need to travel that distance. Then we get into our loop function. We call the drive straight function. Then we time a delay. Then we call the drive straight function, and we go in reverse. And then we sit and wait for the button to be pressed again. So the drive straight function is where most of it is. It's built to allow for positive and negative numbers to go both forwards and reverse, which is why you'll see the absolute value of the encoders. What we do is, this is set up for the report, came out of one of your files you sent us, so you used it to build the report to send for the serial connection. One thing I did do was have to separate the variable declarations from the reset, because when it comes through the second time, it's getting the count, which is already set from the first time around. So right now we're resetting the encoders and we're setting the count variables to 0 separately. Then what we do is, these are variables that are set for our initial speed. I separate the initial speed from the actual speed of the motors being set, so that way we can compare. When we get into our while loop, again, both of them needs to get to the number of pulses it needs to be. We get the count, absolute value like we talked about, but then down here in our comparison, what we do is we compare our right and left encoders. If they're greater than 2, then, and it also has to have the speed within 4 of the original speed. The reason that those lines are put in like that is because it allows time for it to go plus or minus 4 above the initial speed, but gives it some time to actually catch up. What I found was that without that, it would drive it to 0, and then it would drive it all the way up to large numbers, and then drive it back down to 0, and you couldn't get any consistency. So this holds it, kind of helps like a PID loop, just try and keep it in check so it doesn't outrun itself. And then, so as we adjust the speeds, we set that left speed, the right doesn't change. We send our data to print. Once that while loop is done, the motors stop, and it goes back. All right, so we will go ahead and we will upload this. Upload, filing, blinky lights. Still uploading, blinky lights. All right, we are done. Let's take it onto our test chart. The black lines are set for exactly 36. One thing I did find was most of the error that I was getting was due to setting it up wrong. So we're gonna see how this goes. Not bad. See, it's running pretty straight. Got it off a little bit there. So right now we are about inside of an inch for sure, half an inch for sure. Go ahead and do it again, just to show. All right, set it up. Yeah, see, I set it up crooked that time. I mean, it's going straight. Just seems like all my error is most certainly in how I set it up.